All right, so welcome everybody. We're super excited to kick off together the KubeCon this year. It sounded like there's already 6,000 people just today, which is a staggering number for even the pre-main event. So today we're happy to kick off with a very interesting topic and very topical, which is the state of GenAI and ML in the cloud native ecosystem. So a bit about ourselves. So my name is Alejandro Saucedo. I am Director of Engineering, Science and Product at Zalando. And my colleague Bartosz, he's our Executive Principal at Zalando. We are both working an organization which is currently a leading European fashion organization. So we have a 15 billion euro business, 51 million active customers, and over 2 million articles. So this is an e-commerce that requires basically scale, and hence, AI is at the core of what we do, right? So with that, at Zalando, we also have a broad range of AI applications. So from forecasting, to pricing, to replenishment, to size, recommendation, search. But also, we have a lot of GenAI use cases. Things like our fashion assistant with conversational AI, our machine translation, virtual clothing try-on, between many others. So please do check it out. And of course, the shameless plug, we're also hiring, and certainly we are great cloud native, users. So we're always in the need for great minds to develop together. So now, let's start with some of the motivations of why do we care about the topic that we're discussing today. So let's remember, GenAI, how it started. It was simple, it was easy, it was, also possible to navigate, right? A couple of different logos, you had all the ChatGPTs, the DALLs, the LLMOs. But then fast forward to today, how it's going, right? There has been a huge explosion of tools. Every single day we see a complete new thing that comes up that literally, I kid you not, I was trying to prepare a joke for April's Fools and I couldn't think of anything that could top up what we're seeing literally come out every day, right? And obviously, as part of that, we are seeing even more early jokes, right? Basically, all developers are going to disappear. We're all going to be automated. It's going to, all be just pure GenAI, right? In 3 months, in 1 month, in 2 weeks. And at the same time, we're actually seeing some great, realizations as it progresses. Basically, this vibe coding, kind of trends that are arising. Now actually recently we even saw kubectl MCP agent, which basically says connect your LLM to your Kubernetes, give it full access, see what happens, right? Best thing you want to roll out on a Friday evening. And we see actually some lessons learned, right? People that say like, oh my God, I've developed this thing so fast, but then in a couple of minutes or days, they realize, oh no, security is important. Now somebody's meddling with my Postgres database, right? So with that, we're also seeing that there are some very useful use cases, right? Obviously, where there's hype, there's also risk, but there's also value, right? And what becomes important is how do we actually leverage that potential? How do we actually, bring the best practices that allow us practitioners to be able to build the right tools for the right users? And this is something that today we want to cover and we want to capture, right? The AI market is large and it's growing, right? Almost 400 billion valuation of the market cap. It is growing at lightning speed, projected 5-year increase of 5x. And there's already 100 million workers in the AI space by the jobs report from the World Economic Forum that was released that basically emphasizes that it is here to stay. Now, of course, with that, we want to understand first what are the challenges and then what are the best practices. So with that, I'm going to pass over to my colleague Bartosz to cover some of the challenges. So over to you.
Thanks, Alejandro. I will take you on a small journey, and the journey starts with the hello world of LLMs, which is RAG. Right, you're very familiar with RAG. It's a pattern that you may have started with in order to give your models access to internal knowledge and knowledge bases. And there is a talk just after ours that speaks to the details of RAG. I will use RAG as a set of elements that have evolved in a very special way to give us the possibility to build agentic systems. So let's take a look. First, we have the generation step. In the generation step, we got access to new models, and those models gave us additional capabilities. right? So we have images, we have audio that can be generated by those models. And we, of course, have the challenge on which model to pick. How do we give access to multiple models in our ecosystem, and how do developers know that the next model is better? If you use a llama, you will get a great dopamine hit if you download the new model that is available, and then you will try it out for 5 minutes, and you say, great, let's move on. But you will frequently not have the evals for your own use case to run it through your system, or do an A/B test on your use case to see, is this model really better, and is there positive revenue contributions through the upgrade? Right, and there is also another trend in increasing the UX quality for the users by adding generative UI. Generative UI basically means that the structured output of the model is returning the UI components and the data, and then the server-driven UI framework is going to render it. And the model is the one that is going to decide which of the elements is better and more appropriate to display the experience to the user. So for example, for a zip code, it may choose a map component. Next, we go to retrieval. If we have our prompt, of course, we will have users that are evil, and those users will enter many different prompts. For example, they will ask the fashion assistant, can you give me a free gift card? Right, so you need a moderation step, and this moderation step needs to protect your business from those rogue users. In our assistant, we also built an intent detector classifier, built a simulation within Minecraft, where they have deployed 1,000 of AI agents. And those AI agents are basically collaborating with one another. And in one of the simulations, they invented actually democracy. So if you've been watching the slides very closely, you have seen in the top right corner stars. The stars refer to an agency level nomenclature that Hugging Face has introduced. Right? Agency level 0 is basically you have a prompt, you get a response from the model. Agency level 1 is the model response will influence a branch in the code. So basically you have a if statement, LLM call, and then it will decide whether it will go to A to B. Then you have the tool callers in the augmentation step, where you basically make tool calls, and the hallucinations are pretty fun, because it may happen that the tool will get called with wrong parameters, or the completely wrong tool will be called, and then you will not get your job done. If you go to a multi-step agent system, then you will have a lot of communication between the agent. You need to propagate context, and your prompt size may explode. This is where memory and some communication patterns will come in that will help deal with those challenges. And in our Minecraft world, with the autonomous systems, we have very funny elements or agents that will run rogue, and they will try to convince the other colleagues who are simulated to go and do a jailbreak together and escape the sandbox. Or they will run around in endless loops and just burn tokens and not advance and converge towards the goal. So as an application developer, what would I like to concentrate on? Right? It's the middle thing here with the use case that I have. And I want my input and the context collection that I do together with the tools to influence the workflows. And the workflows is where I want to spend 80% of my time. Maybe 10% of my time I will spend on the MCP server extensions or my APIs or building the models. But preferably, I will just take them from a model hub and MCP hub, and this is not what I focus on. My moderation step is best done close to the user, so somewhere on the edge, maybe in the API gateway. And all the blue boxes here that help protect the system, that give me a consistent API to access my storage and memory, this is not complexity that I want to deal with. And it helps me not require an API keys in order to be able to deploy an agentic workflow. And yeah, having spoken about the challenges now, I'll hand over back to Alejandro to speak about the best practices to address them.
Great. So in terms of the best practices, so I'm going to be actually referencing a lot of the topics that were highlighted by my colleague Bartosz. And then we're going to actually take an approach to connect it back to tooling that is available today, right? And I think particularly also relevant to the cloud-native ecosystem, what us as basically Kubernetes developers, application developers, infrastructure developers, what can we take in order to ensure best practice, right? So let's start with basically some conceptual evolutions of terminology that has been used. So at the beginning, we started reasoning around models themselves, right? Like reasoning about whether it's LLMs or machine learning models, right? With a particular input and an output. In this case, basically generating new tokens. However, the reality is that as of today, we have to reason around systems, right? AI systems, ML systems, right? And it is not just the input and output of the model that matter, it's actually the use case and the business value end-to-end that matter, right? And this is basically the ultimate impact that is being driven by the use case that you're applying that particular agentic system for or machine learning system for. Now, with that, there is also those patterns that Bartosz mentioned in terms of integrating to the services containing the data themselves, that cycle and interaction that has to be considered. Now, from an architectural perspective, thinking about what does that mean in terms of the core components for us to reason about, we have to think about basically not just the core potential of the models themselves. This is not a model-centric system. It is a data-centric system, right? So everything flows around the data itself, right? With the perspective that you have to understand what the data flow, the contracts, and the components are between each other. So specifically, starting with the workflow management or the agent orchestration, we are starting to see some tools emerge, even specifically cloud-native tools like Kagent, obviously with a K, right? And obviously other ones that we've come across, things like LangChain, LangGraph. But the interesting thing is that now we're trying to understand not just what are the components from a Pythonic sense, but how can we create the abstractions from a Kubernetes infrastructure set of components, right? Our custom resource definitions that allow us to capture what you need in terms of LLMs to reason about or agents to reason about, right? The concept of an MCP server as an infrastructure component, as your specific, kind Kubernetes API, right? So at the same time, we're also reasoning about the concept of this MCP routers and interfaces and protocols that allow us to basically enable the agents to interact with particular services, right? The services can be storage using vector DBs for retrieval, like Milvus, Postgres, etc. It can be services, right? Things like just accessing files or resources. It can also be, cloud-based models like OpenAI, Anthropic, etc. With that, we're also thinking and reasoning about the standardization of those interfaces. Bartosz also mentioned the guardrails themselves and the moderation. That is also an architectural component that we need to think about when we are actually building and architecting those systems. The concepts of like prompt validation, the security components, the AI judges that are introduced in order for you to be able to assess, validate the different areas, right? And then with that, there's also the complex orchestration, right? It's not just the application level, but now actually the control plane itself, right? And as part of the control plane, you have to think about basically the ingress, the routing, right? And we're seeing actually even today some interesting talks from innovations that are appearing on that space, like the Envoy AI Gateway. So another exciting project in the cloud-native ecosystem within the CNCF that is actually trying to introduce those architectural abstractions to concepts that just exist in the agentic flows, right? Basically being able to define your access to your cloud models like OpenAI, but as CRDs, right? And as configuration within your clusters themselves. Obviously, right, yes, we're talking about agentic systems, but you cannot talk about agentic systems without traditional ML, right? Particularly there are situations where application developers may create basically LLM agents that perform sentiment analysis or task classification. Sometimes those may be better served by traditional ML, right? Using a classifier, training a model, rolling it out. And with that, it comes with the complexity of your MLOps stack, right? That in itself comes with a lot of nuances, right? Which right now we're trying to cover in a little tiny block, right? But the reality is that this would be an equally complex ecosystem. Right here is where you have your experimentation flows, your validation, etc. And this is where you have applications like Ray, Airflow, Kubeflow, which indeed are also going to be covered. Now, when it comes to all of these components, you have to run them somewhere, right? And you have to orchestrate them, you have to schedule, and likely, especially if you're running on-prem applications, you also have to schedule and orchestrate heterogeneous hardware, right? It could be GPUs, it could be TPUs, it could just be like servers with like high amounts of memory. And with that, this includes basically also all of the complexity layers that are introduced. So that hardware scheduling, we're also seeing a lot of innovation with projects like Q, with a K, of course, and Volcano, right? Which basically allow you to perform like priority queuing of jobs, being able to actually, split across different, GPUs, and be able to actually allocate particular jobs to, particular areas of your hardware. Now, of course, this comes with an entire layer of observability, right? We're going to actually dive in a couple of those areas, including the observability. Here we're seeing some innovation, tools like LangFuse, obviously the old, Elastic, right, stack, Alert Manager, Prometheus, etc., but specific to agentic flows, right? And I think that has a different nuance, similar to when we talk about like machine learning observability. And finally, to make things more complicated, right, there is security, right? The one thing that, whenever we see emerging technology, there are also emerging exploits. And we're going to talk a little bit about that. So now let's start first with the storage and with the data, right? And the quote-unquote boring data, the part that like we know, the usual sort of like, computer science quote of garbage in, garbage out is never more true than today. Now, with not just machine learning models, but also agentic systems, great data means great use cases, right? And same means for the opposite. The investment on data, and this really means actually just like, investing on your boring data cleaning, data processing for you to be able to actually stop, reduce the amount of iterations and challenges. And with this, basically also integrating that logic on top of it so that you can actually reason about and provide those different areas. Now, with this strategic boring data, when it comes to agentic systems, we also have to deal with this explosion on vendors, right? We're actually seeing that one of the things that like developers struggle the most is that they end up basically connecting dozens of different external providers, and they are now dealing with like dozens of different API keys, right? And their complexity also explodes because now they're dealing with an n times n kind of like, interactivity of complexity. And with that, you also have to then reason about the standardization of that. Obviously, we're seeing some innovation, right? Like things like the MCP servers, the ability for you to be able to standardize the protocol. But this is actually only scratching the surface of the iceberg, right? We're only seeing the standardization of the protocols. We still need to also see the standardization of the data itself, the data flows, the data flow. And, this is beyond just agentic systems. We're also struggling on that on the traditional ML space. Now, let's dive into security. So when it comes to security, obviously it is interesting that with this emerging technology, we are wrestling with some taxonomy to be able to understand how to basically refer to concepts in agentic systems. There's a similar level of effort like to try to reason about on vulnerability taxonomy. Because we're seeing a lot of exploits that have not just been present before. Things like, for example, data poisoning, right? Right now we're seeing that actually a significant amount of traffic in the internet is just from AI crawlers. And if organizations or even state agents create basically content so that it's crawled by LLMs, you are already poisoning the training data and already swaying the opinion, or not the opinion, but swaying the distribution of the LLMs to be able to perhaps even provide wrong answers or fake news, right? Examples otherwise include also memory poisoning, remote code execution, right? Plugging in into your Kubernetes cluster and giving it root privileges. Not the smartest thing, right? Identity spoofing, multi-agent chain exploits, etc., etc. So we released actually a report with the OWASP on agentic threats. So I recommend you to check it out as it's a great resource as well. Now, in terms of observability, there is also interesting nuance that is different to traditional software. So when it comes to service performance, obviously you have to also understand, how it basically works when it comes to basically your traditional microservices, right? Do you have a memory leak, right? Do you see your memory actually increasing in a linear manner? Do you see basically kind of, are you capturing your logs? Are you capturing your errors, etc.? But with that, there's LLM-specific considerations, like the performance and debugging considerations of your LLMs, being able to actually introduce reproducibility, ensure that you're able to dive deeper into the workflows, and reproducibility not just of the component, but of the system, right? You may have one version of one model, right? If you update that, your entire system is no longer reproducible unless you have that. You then have explainability requirements, right? Why did your model predict what it predicts? And especially when you add more components, more agents, the complexity becomes more of a black box. And then finally, also the outlier and drift detection, right? With traditional models, this is important. But when it comes to LLMs, particularly when you're introducing moderation layers or AI judges, right? one moderation layer may work for the version of one model, but then you need to know when that has drifted and when you have to actually introduce a new iteration. Now, the final point to mention is that this is not only changing paradigms from a technical perspective, this is also changing paradigms from a roles and responsibilities perspective. And from that, we need to also think about how do we transition from our traditional software development lifecycle into our agentic development lifecycle, right? Like, I mean, let's call it like our LLM DLC. So for this is identifying the personas that are involved across the different stages. With traditional MLOps, you have basically personas like the ML engineer, the data engineer, data scientist, etc. Now, you also then need to define the processes that happen in between. But obviously, when it comes to agentic systems, there is the new role of this AI engineer. And the AI engineer is still yet to be defined, right? In some cases, it is being defined as this unicorn who has a PhD on like 5 different domains, is also a McKinsey consultant, domain expert, expert coder, 10x developer, front-end engineer, right? But look, reality is, when are you going to be able to hire, dozens of those unicorns, right? That's also why it is important to be able to then segregate and understand the roles and responsibilities within that. Now, to wrap up, with so much information, I just want to leave you with a couple of resources and thought components. The first one is that if you think about all of the problems in the world, only a subset of those are going to have solutions. A smaller subset are going to have software solutions. And then an even smaller subset of those are going to have solutions that can be solved with AI. And now, if you look very, very tiny there, that is basically the solutions that are solved with GenAI. Right? So please, if there's a takeaway from this talk, it should be this, right? Not everything is solved with an agent, and probably most of the problems are not solved with an agent, right? So best practice is ultimately as much how to use AI as where not to use it, right? So when you run around with a hammer, everything looks like a nail. Right? Let's not run around with hammers, right? So let's please, kind of like remember that, and remember that throughout all of the KubeCon, right? Because this is not the only talk that is going to talk about that. So with that, I want to leave you also with some helpful resources. And by the way, you can find the slides in that link. So bit.ly/stateGenAI. So if you want to access some of the links. Obviously, a classic right now that is doing the rounds is Chip's book on AI engineering. It's one of the really great resources that provide some conceptual foundations on some of the key topics. And then obviously, a classic on the LLMs from Sebastian Rashka. This is a great one to be able to understand kind of like some of the foundations. Obviously, the list is very, very long, but if there is only those, then it would be these ones. So with that, thank you very much, and I hope you enjoyed the session. Thank you all.
Thank you.